Hi, welcome everyone. Thanks for joining this webinar today with SME, Storage Made Easy, and OpenIO. Our topic today is providing next generation enterprise file services through software-defined storage. I am Marie Poncel, co-founder and VP of marketing at OpenIO. So few points before we start. This webinar is recorded. The video will be sent after the presentation. If you have any question or feedback, feel free to ask them at any time in the GoToWebinar app. We'll be happy to answer at the end of the presentation. You will find two attached documents in the GoToWebinar app, a solution sheet and a white paper. You can download it by clicking on the Documents panel in the app. So I'm happy to introduce our two speakers, who are Enrico Signoretti, Head of Product Strategy at OpenIO. Welcome, Enrico.
Welcome. Good morning, everyone.
Welcome. And Steven Sweeting, Product Management Director at SME. Welcome, Steven.
Thank you, Marie. Hi, Enrico. Hi, everyone.
Hi. The agenda is divided in 4 parts. First, so we'll introduce OpenIO and SME. Then we'll see how OpenIO and SME work together to help organizations provide superior next generation services. And then we'll make a demo of OpenIO SDS and Storage Made Easy File Fabric. Before starting, I would like to submit a very quick poll. So what is your major concern when it comes to enterprise file services today? It's about cost, security, ease of use, backup, and disaster recovery. I'll let you a few seconds to answer. All right, thanks. I will share the result with you at the end of the presentation. Okay, thank you very much. I am now letting Enrico starting with the first point.
Okay, thank you, Marie, and welcome again to this webinar. I'm going to start the presentation with a few slides talking about OpenIO and how we do object storage. But first of all, let me introduce why object storage, okay? So there are several types of storage infrastructure and storage protocols now. And we usually use block in the data center for FC and iSCSI to connect virtual machines or databases, this kind of stuff. And this is very good kind of storage because even though it's not very scalable, usually it gives a very low latency and a high number of IOPS. On the same floor in the data center, you usually find NAS systems, and they are very good for in the local networks, and they are close to the clients, but actually they are still limited in scalability sometimes, and they are actually really difficult to reach from mobile devices like phones, for example. In fact, object storage overcomes all these limitations. So it's accessible from everywhere because it uses protocols that are thought for the internet. A single element, a single file, a single object, a single volume could be accessed by millions of devices at the same time. It provides high throughput, high parallelism, and also higher latency. But actually, this is not a problem because most of the time there are limitations in the path between the device and the storage system. These systems are usually scale out, several petabytes or exabyte, even though they can start very small sometimes. And the fact that they are compatible with all the systems that we can use, from the PC to the mobile device, it's very important to distribute data all around the world, especially in very distributed organizations. So the difference between object storage and NAS or block devices is also around the fact that usually object storage systems are multi-tenant, so they can do a lot of things. In fact, we used to call them object storage infrastructures and not object storage system, which is probably less gives less the idea of what you can do. We usually have the ability to run multiple workloads on the same infrastructure. In fact, as you can see here, the same infrastructure can serve archive workloads, backup, email in the case of OpenIO, and thanks to our partner SME, for example, also file services and sync and share services are available on our platform. But it's also good for big data, web application, and so on. We at OpenIO have these three important messages that are coming with our vision. So one is that we do everything on object storage. It means that we can scale from 1 terabyte, which is probably the smallest of the installation you can have with our system, up to exabytes. And we have an important differentiator compared to other object storage in the market, which is called conscious technology, that I will introduce later in this presentation. But also we have we are open source. It means that you can download the software and install it without any limitation. It runs on commodity hardware, so x86 and ARM servers, to reduce the cost and the TCO by separating hardware acquisition from software acquisition. And we also have an event-driven data processing framework, so we can run application directly in the object store. So why we are different? Okay, first of all, our object store is not based on traditional hashing table mechanism, but actually we use a different kind of distributed hashing mechanism, which is based on a set of directories. It allows us to be much more flexible in the configuration of the cluster, and in fact we don't usually refer to our cluster as a ring, as many other object stores do, but as a grid. And by collecting information on all the nodes, we have two very important capabilities. One is that we don't need to rebalance the cluster, never. Okay, every time you add a node, it is possible to add it without rebalancing the cluster. It means more performance, and also it means that you do not have to wait too much time before taking advantage of new resources. But to be sure to get always it right in terms of performance, okay, and the resource allocation, we use what we call conscious technology, which is a mechanism that collects sensors in all around the system, and it computes a quality score. At the end, you have that for each single node, we know perfectly what is happening. So the capacity used, the bandwidth used, CPU consumption, and so on. So we can decide where to put data in each single moment, and it helps us to balance the data in real time and get the optimal performance for the cluster all the time. And again, thanks to the Grid for Us framework, we can choose where to run applications directly close to the data. It's very useful, this kind of approach, for example, to run application that can check the validity of data, can add metadata to the data, and so on. So as I told you before, our software is open source. Okay, it means that the code is available on GitHub, and as well as the packages are available, and the box in yellow are all the open source code. You can download and install the software for free on any x86 platform and ARM computers. On top of it, we have several connectors that allows to serve additional workloads. Okay, there are some email connectors, enterprise version of Grid for Apps, a web user interface, and they come with additional subscription. So just to recap a little bit of what I said. So first of all, flexibility. OpenIO is a very flexible object store because it's dynamic load balancing capabilities. It supports multiple data protection schemes. It means that we can start with a minimal configuration of 3 copies, but we support Razor coding. And we also support multi-cloud installations. It means that you can have the product installed on premises, both in a single data center as well as a multiple data center. Geo-replication is supported, for example, and stretched cluster are supported too, but you can also decide to have a second cluster deployed on the cloud, for example, and this could be done, for example, if you don't have a secondary data center. And the product is really easy to use. So the command line user interface is very simple, but also the web UI helps you go through the administration and day-to-day tasks. It's lightweight. It means that it can run on one CPU core and 500 megabytes of RAM, and it can run on 10 heterogeneous clusters. So in the same cluster, we can have different types of hardware, both in the same platform. So you can have high capacity nodes and older nodes in the same cluster, for example. And we support x86 and ARM CPU, and as well as cloud and edge infrastructure deployment. Open source. So all the software, as I told you, is open source. The licensing model is very OpEx friendly, easy to adopt because it's free to download. So the POC can be set up in a few minutes, and our customers are telling us that the return on investment is very high. And fourth point, serverless computing. So you can do in-place data processing directly on our platform. If you are familiar with the concept of functions, Google Functions or AWS Lambda, our framework works in the same identical way. So I think that my part is finished, and I hand over the microphone to Steven.
Great. Yes, thanks, Enrico. Thanks a lot. If you guys have some questions about this first part, please ask them in the app. We'll tackle them at the end of the session. So Steven is going to introduce SME. Please go ahead, Steven.
Thank you, Enrico. So let's touch on just trying to get control. Enrico, perhaps you could next on the slide. We'll first touch on the top challenges with data today, and sort of data growth and data security, and how OpenIO together with Storage Made Easy can address these issues. I'm not seeing the slide, so just bear with us a few seconds. Yeah, if Can you forward? And next. Thanks. So data is growing exponentially, but unfortunately budgets are not. Object storage, and OpenIO in particular, addresses the cost side by being able to reduce hardware, use commodity hardware, and also reduce, of course, the administrative costs because you're offering the self-healing, self-balancing, and self-scalability. So we have this sort of web scale performance and reliability. But the challenge here is how do we support applications and end users who don't yet speak object APIs? How can they leverage object storage too? Next. So the growth in data and also this sort of increase in data silos, that increase in the data locations and the different vendors, of course, now in the cloud, makes it more difficult for IT to enforce corporate data security policies. Of course, we're already dealing with cybersecurity, the cybersecurity arms race and changes in regulation. Next. So data leakage occurs when confidential information becomes available to external parties. And only half of data security breaches are actually malicious. The other half are relating to something that happens accidentally within the organization. About half of those are due to employee oversight. They don't realize what they're doing. And about half are due to poor business processes. Of course, part of the problem is the employees don't have compliant tools for sharing data in the first place, sharing files with vendors and partners and customers. And they don't have tools that are really good for working out of the office, mobile, work from home. 65% of employees admit to using unsanctioned file sharing tools, and we think the other 35% might be lying. And of course, why are they using cloud services in the first place? Certainly because they're not, even if they're not compliant. Well, they provide a faster turnaround than IT, better usability, self-service, and then make it easier to collaborate outside the organization. Next.
Stephen, you should have a full control now.
Thanks. So yeah, in terms of regulatory challenges, we just ran a survey where 50% of employees reported that their organizations weren't ready for the forthcoming European General Data Protection Regulation. For those not familiar, the so-called GDPR is extensively reforming data privacy and protection for companies handling EU data. So what do we do about this? Well, Storage Made Easy offers an access or control layer that enterprises can use to wrap around their data on-premise, file system, private or public cloud. For IT and compliance, this layer sort of creates a single platform, a single namespace for access control and governance. And for end users, they can see the storage through the single namespace and have the ability to securely share information inside and outside the organization. So it's a solution for IT and everyone as Storage Made Easy. We've got the ability to access data stored in OpenIO through mobile and desktop apps. We have a single pane of glass for IT for data governance and security policies. We've got the ability now for a corporate Dropbox with an on-premise file sync and share. And with multi-vendor support, we have the ability to do cross-provider backups and migration much easier. Let's touch on some specific governance and collaboration features before we do the demo. Some of the capabilities of Storage Made Easy File Fabric around governance are client-managed encryption, corporate file sharing policies, such as requiring an expiry and download limit, even requiring a reason to be logged, file locking and versioning, archiving folders and trash, great at preventing accidental data loss, DLP, data loss prevention capabilities, a number of security policies, in particular focused around the cloud. For example, policies based on the location of the client or the location of the data. We also support detailed audit logging for both historical purposes, what happened, but also for real-time monitoring as appropriate in some situations. On the collaboration side, we have the concept of team or project workspaces, a number of different options for sharing files and folders internally and externally, approval workflows, the ability to add comments and see history of changes to documents. It's also supported by Office plugins and Outlook. Enterprise integration for single sign-on, integration with identity providers, and the ability to annotate PDF files and the ability to do Office editing through the web. And just a quick mention, a call out to standalone apps. In addition to Storage Made Easy's full stack file fabric, we also have standalone apps for the Windows and Mac. These provide the ability to access OpenIO SDS through a local drive or Explorer interface without the governance layer, the overhead of a file fabric. Okay, let's begin the demo.
Thank you very much, Stephen. Maybe before we go to the demo, I would like to submit a second very quick poll for you guys.
Thank you.
Okay. So do you need to manage data on premises? So is it yes, I work on a highly regulated field? Yes, it's faster, it's cheaper. Yes, I have better control, or no. So I let you a few seconds to answer. Okay. Great. Thanks a lot. Okay, please go ahead, Stephen.
Okay, so for this demo, I'm using a Windows virtual machine. I'm connecting to our SaaS service in North America with a 5-person organization. So I'm actually logging in as a tenant within the service. The solution is typically deployed as a multi-tenant appliance on-premise, in the cloud, or as a managed service. So I've logged in as an admin. Two-factor authentication is also supported. And the default starting point's the home page, which lists the major tasks I have based on my permissions. I'll jump to the cloud provider dashboard. We'll have a look around. So as an admin, this is where I manage the connectors to different storage providers. So File Fabric supports different, as we've talked about, many different types of storage providers and a number of cloud applications, including object storage, traditional file servers, FTP and public clouds, applications like Salesforce. You can see here we've got an OpenIO provider, maybe providing some engineering files. We've got a cloud provider here, maybe providing some offsite storage, bubble backup. We have here some default storage from the appliance that's provided as tenant. And here we've exposed looks like a website over FTP. That is, we've connected to the website over FTP and making it available within the file system, within the file fabric. Individual users can also add their own private accounts. We can see here just a list of these. We can't access them even as an admin, but this is a great way for end users to make available, to provide corporate oversight to their personal accounts, as well as make it easier for them to move data, maybe just to sanction data stores. Okay, so let's add a new provider. I can choose from over 55 different on-premise or public private cloud storage and applications here. If I wanted to, I could choose a backup provider. A backup provider that transparently replicates changes on the primary. It can be a completely different vendor or technology, of course, not to mention a different data center. So here I'm going to add another OpenIO provider. Maybe this will be my marketing files for Marie. Oops. And what happens now is that FileFabric's going and asking what buckets are available to pull in. I'm going to pull them all in, maybe default. And what SME is doing now is going and pulling in the metadata from the objects that are already within the object storage. So here it looks like it's picked up some white papers and other collateral. Okay, that happens in the background. We can also schedule that at to happen automatically in the background, or if a fixed interval, if we have other applications that are modifying data at the object storage at the same time. Okay, let's so once we've indexed the source providers, we can present present authorized views of files for other users. We can access that data across desktop and mobile clients and through APIs. We can access through mounted drives, FTP, WebDAV, and Office applications. So let's look at a few of those. This is the web-based file manager. It provides a familiar view, into this case, object storage. What we'll do is just to refresh here to pull in our new data we've recently indexed. Now this data is available for the admin. If we jump into marketing, marketing does not yet have access to that data. So what we're going to do is maybe we'll take the collateral, we'll mark that as a shared folder, I'll add some permissions, and here we have not just the default, your sort of traditional ACLs, your ACLs, but also things like uploading files, downloading, creating shared files, shared links, web view. So some sort of cloud-oriented views. So we're going to give sort of full permissions here. Now that we've done that, we can see the folders marked as a little profile here for a shared folder. And if we go back to the marketing view, we're now seeing this folder as a shared folder. What's great about FileFabric is we can translate user-oriented actions into or hierarchical sort of file and folder-based actions into object storage. So marketing is our OpenIO object storage. From here we can create a subfolder. Oops, that won't work, will it? And what's happening on the back end is a new bucket is being created. From here we can upload files or drag and drop. So very easy to move data in and out of storage. We could even do things like rename. So these are operations that object stores don't permit, but what FileFabric does is takes care of the underlying operations to support that. It will, for example, rename the constituent objects to give a very good user interface, a user experience rather, to end users and applications. Okay, let's look at a bit more detail at some capabilities within the file manager. We'll jump into file here. Okay, so here's an example. We have an Excel spreadsheet we've uploaded. You can see here a number of revisions is 4. We've made 4 revisions, 4 changes, and based on the settings, we've kept a log of those. So this is great for auditing purposes, or for maybe files may accidentally changed or deleted. You can also choose to hide those versions, so the end users don't need to see those versions unless you want them to be. So depending on your corporate policies. We have the ability here, of course, to download the file, mark as a favorite. We can preview the file. We'll get a web preview here, what the file looks like. We can see information about where and when that file was uploaded, modified time. For audit purposes, we can even tell where it's physically stored, what data center, where it's uploaded from. We can see here we've got a number of shared links, and we'll touch on those a little later. We can see this link as being it expires in 4 days or after 2 downloads. We also have a thread comments for folks to talk about what's happening to files, to mark the updates to those files, and we'll see how they're visible in other clients as well. In terms of sharing, a few different ways. Certainly sharing internally, we can share with groups or individual users. For external sharing, we can share, we can create a link or send information by email. I have a number of options here. We can use a tinyURL or one you've set up yourself. We can also choose things like the link will expire after 10 days. The user can only link it, can only download it twice, and has to enter a password. That will then generate a link that we can use to send over whatever mechanism we like, instant message or email, or embed within a document. And as we saw earlier, we get a track of an audit trail of what links have been created. This is the link was created with a password and a 10-day expiry. In addition to the file manager, I mentioned there's other ways of accessing information. One way is through a desktop drive. So here the virtual file system has been mounted on our T drive here. If we go into public reports, into the report we just looked at, when we open this file, it's being downloaded from the cloud, opened up in this case Excel, of course. I can also make a comment, and then when I save that, it will automatically be uploaded and sent back to the cloud. In this case, sent back to OpenIO storage. You can see here, we're just the file manager is refreshing in the background, and is marked as a lock. Lock, of course, has been turned off as we uploaded the file. But it's an example of adding file system semantics such as versioning, locking, caching on top of an object store, which is traditionally built for supporting applications. We have these file system semantics that make it easy to access as a file. So here we can see this is the file we just uploaded, and the comment we made saying this is final. Sharing is also available through an Outlook plugin. So similarly, we could go to the file we just had and fill in information here. And it creates a URL here. Okay. On the Mac and Windows, we also have full set of tools for syncing. Okay, so here we have a sync. It looks like, oh, this file has been changed, so we can execute a sync manually, or it can run in the background. Okay, so this is fun for users, but what about administration and about governance? We have the ability for, as we mentioned, a fairly detailed audit log. We can look at different types of activities by users or time or searching. So we can see maybe what's happening with a particular file. This is also great when users report that maybe they've lost something or accidentally mishandled something. It's very easy to go back and see what's happening, see what happened, and recover the file or let them know what's going on. One of the big differences with enterprise file sync and sharing as compared to, say, the consumer products such as Dropbox and Google is the support for corporate specific policies. So the ability to for example, have a very finely crafted file sharing policy based on the needs of the organization, the geography, the jurisdiction they're in. We can choose to say that we require a password every time we share a link externally, or maybe we require that a time limit be set, or a minimum, rather a maximum time set. We can also, actually we've added this for GDPR, the ability to audit why are you sharing this information and who are you sharing it with, for keeping a record of sharing, and of course also are keeping an audit trail of that file actually being shared. One of the popular features is we call it Audit Watch. Is the ability to monitor to create rules that monitor for changes. We could monitor that a file has been created or changed or downloaded, and send a notification, whether it be as an audit facility or a notification, or maybe a security aspect. I think we mentioned we keep a record of shared links for the you saw with the files. We also, for audit purposes, keep a full list, which can also be revoked. Okay, and I think I just want to touch on some other types of governance policies here. So we talked about file sharing policies, a number of security settings, flexibility on choosing what events to log. You can require two-factor authentication. We have now support for the Vault key management system, the ability to set encryptions or allow encryption for teams and folders. So we can actually encrypt the data before it gets sent to the back-end storage, which adds another level of security. Versioning, we talked about the ability to choose whether or not to display versions to end users, perhaps hide them in certain situations. We also have, we can actually touch on it, support for tagging and searching. By virtue of having a complete index of all of the files. So, oops. Okay, I'm going to, I'm not sure if there's any questions, but I'm going to finish the demo here and close off.
Great, great. Thanks, Steven. Before starting the Q&A session, I'm going to share with you the result of the polls. So the first question was about the major concern when it comes to enterprise file service today. And so the cost is the most important for you, 88%. And then comes security, backup and disaster, and ease of use. So the second one was, do you need to manage data on premises? And the answer is mostly yes, because you have better control, then because it's faster, cheaper, and because of the regulated field. All right. Okay, so we already have some questions. So I take the first one. Will SME ever support Linux desktop?
Yes, SME has a Linux desktop client which supports synchronization and access to many of the functions. And there's also a Linux a drive. So there's a fused mount point. You can mount the file fabric and then access information that way. Additionally, there's also an S3 interface in the file fabric, so you can use Linux tools that support S3 or WebDAV or FTP interfaces too.
Okay. Is document watermarking possible and copy print disabling?
That's a good question. Watermarking, we're actually in development supporting PDFs, so that when a user sees a PDF file, they will see a unique version. And then copy print disabling, we don't have support for that. But that's something we could look into if that was important.
Okay. The next one, does SME include a compliant warm file locking?
That's a good question too. So SME, it's bring your own storage. We don't manage any of the storage directly. So it's possible to use us with external storage that supports worm file locking. You can turn storage on sometimes to say create new versions for every file. So we support that model. Our archive model, you might have seen the ability to create a backup provider that acts as a worm. So we don't do deletes, or you could rather configure it so not to do deletes. So we just do, we create new versions for any changes in files. But in terms of worm compliant, that would be a hardware or a back-end service setting.
I can add that OpenIO supports worm objects and worm containers.
Wonderful. So we support it.
So does SME store files in OpenIO in a proprietary format?
A good question too. Unlike some other vendors, SME does not change the file name or the file contents. So the objects are always accessible through external applications, through the serverless computing or other types of clients writing directly to the object store. We call it sort of bimodal. You can access data through SME where it's being audited and governed. So typically that's where your end users are accessing data, and then your applications and can access through OpenIO directly.
Okay, and I have a last one. How can I try this solution? I mean, OpenIO plus SME. Can I set up a demo environment in my VMware infrastructure?
I can answer to this one, maybe. Yes, so both OpenIO and SME are available in a demo version. OpenIO, specifically on OpenIO is the full-fledged product. You can download and install it. We have many customers using it on virtual machine for testing or development purposes, starting at least with one single node, virtual node in this case, for without any data protection mechanism applied, and or a Docker container, for example. And there is also a nice Vagrant box that you can install and configure. On top of it, SME is available as a virtual appliance, so it's very easy to configure and set the environment up.
Okay, thanks Enrico. I think we are done with the question for this session. Thanks everyone for your time. Thanks Enrico, thanks Steven. If you want to continue the discussion, you can find a lot of information on our websites, openio.io and storagemade.com. If anybody has additional questions or feedback, please reach out. We'll be happy to answer. You will receive the record of the webinar in the next few days. So have a nice day, and I hope to see you next time.
Thank you very much.
Thank you. Thank you. Goodbye.
Bye-bye.